Yes, thank you for your patience, thank you for letting me get that spot check in, and thank you for your work last night, but most of us got stuck somewhere. Just a few of us, actually, it seems like you really figured it out. Way to go. Let's just make sure that you know what's going on. Let's see a few harder examples. And if nothing else, probably most of us are at least a little confused on the difference quotient, but a lot of us need to go back and fill in the holes, the gaps of what we didn't get to yesterday. So here we are, section 1.3, finishing it up. Our goal today is to finish, 1.4. Our goal today is to finish 1.4. And if we can, get a little peek into 1.5. I'm not expecting to get far, but hoping just to get like the first page of notes done. So you guys ready?
Yeah.
Set?
Oh, yeah.
What was the last thing we talked about before range?
Domain.
Domain. What are we checking with domain? We're checking to see all possible x values. Domain x, right? So we remember. All possible x values. If you have a graph, you can use this one if you want. It was a calculus one from this morning. I know it's a line, but believe me, the problem was harder. If you see this graph, what question do you ask yourself for domain? Looking at the graph, how left to how right, right? How left to how right. And on this one, guys, how left does this line go? How left does it go?
Forever.
It's a line, so we're just going to say forever, yeah. Negative infinity. And how right is it going to go?
Forever.
Positive infinity. You guys understand the negative positive thing, right? Number line?
Yes.
Positive numbers, positive infinity. Negative numbers, negative infinity. You can have infinite in just one direction, which is a very small type of infinity. Infinite in another direction, very small. So domain, we're asking ourselves the question, how left to how right. How would we then answer in this one? How would we answer the domain? If it's forever left and forever right, we would say the domain is
All real numbers.
all real numbers. Good. Now, range. Does anybody have some blank paper that Kyrie can borrow? Okay, go over to Chris, it's going to give you some paper. We're not going to work on vocab or math, we work on math. Okay, range. If domain is all x's, range is all y's. If domain is all x's, range is all y's. So if domain is how left to how right, what do you think? What question are we going to work on with range? Yeah, but if you're thinking like lower to higher, that's how we usually go in a number line. Don't say how up to how down. I would rather say how down to how high. Or I would say how low to how high. Is that better?
Yeah.
Makes me easy. Might be a good thing to write down with range. It's not specifically up there. If you're visualizing a graph, you're trying to say how low to how high. How low does it go? How high does it go? Yeah? How left does it go? How right does it go? Looking at that line, guys, how low will it go? It's going to go down low. How low?
To negative infinity.
To negative infinity. Why? Look at the y, tick marks. Is every single y going to hit a place on the line?
Yes.
Yeah. So it's going to go negative infinity down. Is every y as you go up going to also have a place on the line?
Yes.
Yes. So what's the range on this one? All numbers. The dilemma is, what if you don't have a graph? The dilemma is, what if you don't have a graph? Those are supposed to be indented the exact same amount. I apologize. Maybe that's why it wasn't awkward. Anyway, let's get to the best advice that I have for range, and I know this is a bummer, is to visualize the graph. The best advice. I'm actually just going to go ahead and write in the how low to how high. Domain, I can give you guys a list of, and by the end of this year, probably by the end of this semester, we'll have gone through trigonometric graphs. We'll have gone over exponential functions and logarithms. So I'll be able to finish that list that we started yesterday. Roots, roots, and then we did denominators. Then we'll do logarithms. Then we'll do trig. Maybe we'll do trig and then logarithms. I forget the order. And piecewise functions are their own little special deal. But range range, I can't give you a list of 5 problems. I can't give you a set way of looking at a function and figuring out what the range is going to be. And that's where the bummer is. Because domain, I can give you those 5 things. Look for those 5 problems. If they're not there, it's all the numbers you're done. Domain's actually easy as long as you memorize the problems and you know to look for them. Range, when you multiply, when you divide, when you add, when you subtract, it will affect the y's coming out. So everything that's present in a function that might not affect domain does affect range. Now here's the dilemma. If I were to give you something right now, like, let's do this example down below. I want you to find the domain and range. That was in homework, right? You had to do both. I want you to find the domain and range of the following. Okay? And if I was to give you something that's kind of nasty, let's say, let's actually use the one from yesterday. Or one similar to it. Let's do -2 minus the square root of 3 minus x. Similar to yesterday, I made it a little bit nastier with negatives and minuses and all that sort of jazz. Let's start first with domain. This is a nasty function. It's not super nice. It does have a, do you remember from last year, parent functions? Parent functions, they're the most basic ones. Like y equals x is the most basic line. But as soon as you have y equals x plus 3, uh-oh, something just got shifted, translated, right? Or y equals x squared is a parent function, normal parabola. But y equals quantity x plus 2 squared minus 3. There's been some shifting that's happening. Then we can add in like dilations, right? Stretching and compressing. We can add in reflections, all sorts of things. We're not reviewing all the different transformations that can happen to a graph this section. So let's do the best we can without necessarily getting a perfect picture of what this looks like. You'll be able to get to the point, or we'll practice how to get to the point where we can get this graph. And if you might be able to do it right now. Maybe you know what the square root of x looks like, and maybe you know what the -2 does, and the minus does, and the 3 minus x does. But for right now, we're going to say, I'm not expecting you without a calculator to get the graph, but I also want you to see if you can figure this out without using a calculator. So, first of all, domain. Is there a problem? Yes. What is the problem that you see in the function? Square root. So according to domain problems from yesterday, what do we do with, I think it was green on this one. Just trying to kind of color code it. What do we do with that argument? Take it, solve for, well hold on, we have to make the equation first. 1 second. What do we do with it? There it is, 0. So that it kind of equals greater than or equal to 0. Good. Remember? And this is, some of you need to highlight the domain problem section. You have to, if nothing else, memorize. If you don't have just a conceptual, oh, of course, greater than or equal to 0. If that doesn't happen in your brain when I show the square root, okay, you're going to have to study and memorize the domain problem. Okay. Greater than or equal to 0. And then you guys told me to do what? Solve. So we're reviewing from yesterday. We're solving. We have negative x greater than or equal to -3. Divide both sides by a negative, and do you guys remember what happens? Good. We need to switch the inequality to less than. Okay, we have our domain. But the struggle is, if you don't know what the graph looks like, and if I don't let you go to your graphing calculator, well, how are you going to do this first part? So what are we going to try as a last resort for right now? Table. So what are some points that we can check? Just to see if we can figure this out. We could do one, except I don't like starting in the middle if I can help it. I'd rather start at the beginning. So why not start at 3? Does that make sense? Now I'm not going to make you guys plug in 2.999 and 2.8 and 2.7, but start at 3. What's the next one we should probably plug in? Then 2, then 1. Let's plug in nice numbers and see what we see. This does not necessarily work on every single function, but for right now, it's the best we can do until I can review with you guys all the different transformations of graphs with all the different parent functions, which are coming. But for right now, well, if you don't know what the picture is, and I say try it without your graphing calculator, let's plug in 3. Let's plug in 2. Let's plug in, we could do 1. Let's just get to some negatives. Is that okay? I'm just trying to get to some negatives. We're going to run out of room. So you can plug in just a few points. I do some positives, I plug in 0 if it's in the domain, and plug in some negatives. Now we're going to go kind of quickly. If I plug in 3, we're just going to do mental math, but you guys theoretically should probably set up like a, hey, what's f of, well, I guess I can show you this, can't I? If I want f of 3, right? Plug in x is 3. What does that mean when the inside changes in the function notation? Change the x in the expression or in the function, right? So I could do -2. I'm not going to do this on every single one. But in the x spot, in where was previously the x, that's called the argument of the function. The argument has changed. There's a substitution that needs to happen. X comes out, 3 goes in. So x comes out, 3 goes in. Okay. What's 3 minus 3? PEMDAS says start in the parentheses or the grouping symbol, which the square root is 0. What's -2 minus square root of 0? 0. So -2 minus 0 is? -2. Okay. Now, for sake of time, any mental mathers have when x is 2? 1.
Nicholas.
Not -1.
Oh, -3.
-3. You guys need to be careful with your negatives. 3 minus 2 is 1. The square root of 1 is 1. What's -2 minus 1? -2 on the number line, left one. -3. Well, these two guys are too. And I have something that will be able to see what we did, just maybe not here. Okay, function notation, two things. Maybe function number one, and number two, showing a function of x. Or like yesterday, we showed volume as a function of radius, or a function of height. Remember, it doesn't have to be x, but a function of somebody, the independent variable. So, name. When we have function notation, when we have, let me just show a normal equation, f of x equals x squared minus 4x plus c plus 7. That's actually what's being modeled down here in the example below. When you see function notation, which is this f of x, the f is just the name. It could be g of x, that's his name, it's g. H of x, j of x, k of x. You don't usually use I of x, because what's I in math usually? Math's very good, so how can you use I? But f is just the name, and the notation, the parenthesis x, is what is signifying or symbolizing that f is a function of x, or f is dependent on x, or x is the variable that is within. Another way of saying it is that x is the argument. It's identifying the argument, or the input of the function. So when you see the f of x, there are two pieces to it. You have the f, which is just the name, and then you have the notation for who is the argument of this function, who is the input of this function, who is the independent variable of this function. Now the one that might be most helpful for you to attach this with is the input. Remember how I said there's a whole group of people that say we shouldn't have taught you x, we should have just taught input, and then taught you x. Maybe some of you learned it that way, maybe some of you didn't. The question is, if this is what you're given as a function, why does it make sense that this is what you should be thinking in your mind? If this is what you have as a function, why does it make sense this is what you should be thinking in your mind? If you guys saw this on like a computer program or something, what would you assume that you're supposed to do there, and then? Input something, right? If something is missing, you're supposed to type it in. If you were filling out like a form online, you have to look at where the different blanks are you're supposed to fill in, right? So same thing here. I've taken out the x, because remember, it's not always x anyway. I've taken out the x, and I'm like, hey, just see every time you see an x, it is a place, it is a field where something needs to be input. And with us in the technology age, hopefully you guys kind of get that in the sense of, like, oh, hey, yeah, I should be able to click on that and type something, click on that and type something, click on that and type something. The x is just leaving a space, ultimately. It's leaving a space for an input. So, if something comes along like f of -1, think about the notation. This, what's in the parentheses, tells us the input. What am I going to do up here in the rest of the equation? Plug in -1. But, don't you dare forget to write a parentheses. It's for your own good, I promise. I'm not just trying to pile work on you. I already gave a quiz on function notation yesterday. I bet if it was only on function notation, I bet over half of us would fail. This is a big deal in the sense of you guys, by the time you get to Precalc, very few of you have mastered function notation and would be able to do it without making any mistakes. So when you guys plug in, when you see what's in this spot and say, hey, if -1's there, we got to copy it in the rest. This isn't one of those where you can choose whatever you want in whatever field. You plug in this and it will plug into the rest. So plugging in -1. Why was it important to write those parentheses? Can you guys do me a favor real quick? Can you type this in 2 different times? Type it in. Don't you dare eat. I don't know why I'm saying outside. Don't simplify. Type it in your calculator with the parentheses, and I want you to type it in your calculator without the parentheses. You can try to make it as proper as you can, but the first one I want the parentheses there, the second one I don't want the parentheses there. Now if you write -4 next to -1, you'll have some issues. Maybe you can put a times in. So I want you to write it with the parentheses and without the parentheses. And the same mistake, the calculator is actually doing it right. The same dilemma that happens in your calculator might happen in your brain as well if you don't put the parentheses. And I'll show you what's going on in just a second. Type it in with the parentheses. Type it in as best you can without the parentheses. But as I said, can you write -4 next to -1 and that makes sense? Okay, so put a time. Just no parentheses on the second. My question is, what are the answers to both? Uh-oh, 2 different answers. What's the answer with the parentheses? 12. What's the answer without the parentheses? So it doesn't mean the same thing with or without? No, here's why. You know what your calculator does when you type in -1 squared with no parentheses? All right, forward real fast. Find the black marker. You type in -1 squared. Your calculator uses PEMDAS. PEMDAS says do what first? Now this is confusing to you. The negative is actually not attached to the 1. The negative, in a sense, is being multiplied by the 1. So it would say parentheses, there are none, but then what would it say? Exponents. It's going to say, hey, I know 1 squared is 1. And then it says multiplication times the negative. And it's like, oh, hey, you know what? Type it in your calculator if you don't believe me. It's going to tell you -1 squared is -1. Check it. What do you think? Poor little dumb calculator. No! You need to tell it what to do. You need to say, no, I need the -1 squared. I'm trying to help you avoid mistakes later. If you put a -1 squared, it's going to say, okay, I can square first PEMDAS, and then I put the negative. Yay, I'm done. But if you put -1 squared, what does it do instead? -1 times a -1, you guys knew this, is a what? Okay. So we're going to simplify. Make sure that you put the parentheses in. -1 times a -1 is a +1. What's a -4 times a -1? +4. And we have 7. And 1 plus 4 plus 7. Mental math is 12. I know to go a bit out of time on that one, but I've seen way too many mistakes happen from people not knowing how to put things in their calculator and not putting parentheses. If you don't put parentheses, you're for sure going to kill some poor little creatures. AKA, you're going to do some bad math. If nothing else, if you don't like the little creatures, you're going to kill some points. Alright, f of t. What's going to change there, guys? The t goes in 1. Where else is it going to go? The rest. You need to be realizing that's what this means up here. By putting a t, I put in a t to the rest of the x spots. This one's not going to necessarily make as much of a difference if you don't put the parentheses. But remember, without putting the parentheses, mistakes are going to happen. So I'm putting them in just to make sure we fully understand what's going on. So guys, what happens when you just do t squared? T squared is t squared. No big deal, right? If I do -4 times t, well, isn't that just -4t plus 7? Okay, no big deal. So if I replace t, I replace t. If it's in the argument, if it's in the of x notation, now it's of t, that's fine. T is the input, t squared. -4 times input, -4 times t, plus 7. Even though the inputs change, the square stays the same, so does the -4, so does the plus 7. So all we have to change is what's on the inside. Now, what's different with letter C? Everything we've done has built to letter C into the mistakes that some of you might make in letter C. What gets plugged in my input? Does it make sense why I can right away write this part of the equation? None of that changes. What does change? What's inside? The input changed. Now it's x plus 1. For those of you that are visual, you can think of f of box is box squared minus 4 box plus 7. Whatever's inside needs to go inside the rest. That's what's going on right here. Okay? Now the dilemma is we're not done because we're trying to be good math students, so what are we going to do next? Simplify. But we have to make sure that here's where the puppy could die, here's where the seal could die. We These are the two big mistakes I have. 2 out of 6, and 2 of them are calculus only. The turtle and actually 3 of them are calculus only. The red panda and the bunny and the turtle are all just calculus. You guys just have this, this, and this as the 3 most common mistakes that I need you guys to avoid while beyond not studying your US. Coming back. How are you supposed to square a binomial? Why FOIL? Isn't it x plus 1 times x plus 1? You kill a puppy if you say, yay, x squared plus 1, done. No. And we'll see why in just a second as to what it should be. Rewrite it. That's why when I taught Algebra 1, I was like, rewrite it every time. Because it's too common of an error. If I see in 8th graders learning Algebra 1, they're taught the right way. By the time I get them in Precalc, if they're still doing it wrong, something happened, right? It's a common mistake. Write it twice, you got a FOIL. What am I going to do with the negative 4? Here's where the seal could die. Distribute the 4. Most people would write that. What do you think the most common mistake is right now? The next step. They say plus 4. What do you have to make sure goes along with the 4? So it's going to be minus 4 plus 7. You know, it's silly. But in math, when you're going fast, that's when mistakes happen. Alright, so what am I going to do to finish this puppy off? FOIL. X times x. Outer. Inner. Last. Minus 4x minus 4 plus 7. Now, the name of the game is, you guys tell me, how do you simplify? I like it. So, I have my x squared. Anybody else to join? No, I have my plus 1x plus 2x minus 4x. 2 minus 4. Then I have my plus 1. I don't like doing like a plus, then a minus, then a plus. I'm going to do 1 plus 7 is 8 minus 4. Because 1 minus 4 is negative 3 plus 7 is 4. Done, so I'm done. Do you guys see how x plus 1 quantity squared was not x squared plus 1? You got a plus 2x in between. You just totally forgot your outer and inner if you just try to do the shortcut that is always in. Just be careful. Alright, okay, it's function notation. Would this have helped for the problems in the 20s where some of you got stuck?
Yes.
Yes. What do you have to beware of? When the inside argument changes, what do you need to change as well in the function? The inputs, the x variables, but what do you need to plug in with those new arguments or those new inputs? Get those parentheses in. They're going to save you every time, okay? As long as you know how to use them properly. Kiddos, we have 2 more slides, okay? Piecewise function. Nice thing is, you saw this in your Precalc graphing calculator handbook. You've seen a graph of it. You've made a graph of it using, didn't you use a divide and like less than and ands and went to that test menu? You've seen pictures. A piecewise function is one function comprised of different pieces put together. Seems kind of random. It's like it's a line 1 second, it's a parabola next, it's a half circle the next, I don't know. It's all sorts of random stuff put together. It's put together with given domains, which we talked about yesterday, given domains, intervals of x's, where this first piece is true, where the second piece is true. As you guys are writing, I'm going to go ahead and write what the question, the example, is actually asking. If you know how to do it, bust it out, simplify, get me an answer, and check to make sure you're right when we go through it. So it's asking for that one piecewise function up above. What would f of negative 1 be? What happens when you input a negative 1? What would f of 0 be? What happens when you input a 0? And what would f of 1 be? What happens when you input a 1? those numbers in the parentheses, you guys should be close to finishing writing it. Each of those numbers in the parentheses, are they independent or dependent? Are they inputs or outputs? Are they x's or y's? Got it. So, if this was like a little baby computer program, the computer program would read this like, oh, I'm supposed to, like a graphing calculator does, I'm supposed to graph this whenever this is true. I'm supposed to graph this whenever this is true. These are the conditions. So if my input is supposed to be -1, -1 would make which statement true, the top or the bottom? The top. -1 is less than 0, true. So where would -1 show up? In this one. So I'm going to go ahead and choose the top piece to be the piece I plug into. I'll come back to that in a second. F of 0 would make which statement true, the top piece or the bottom piece? The bottom. So this needs to be put into, the computer program would put it into the bottom piece. And then F of 1, which one would be true? The bottom. Careful. Greater than is above, right? 1 is above 0, true. So, once again, this will be placed or inputted into the bottom equation. If you can figure out which one it's true in, which piece it belongs in, then you can say, okay, sweet. Plug it in, plug it in, plug it in. 1 minus 1, 0 minus 1. Pencil math, do it correctly. What's -1's quantity squared? What's 1 plus 1? This is what would happen. This is what would happen if you inputted -1 to the piecewise, 0 to the piecewise, 1 to the piecewise. Does that make sense? You've seen the piecewise in the graphing calculator handbook. Algebraically, just wanted to make sure you understood, depending on the x's, depending on the value of the x, you might use different pieces in plugging in. Last one. Whew, good thing we have 5 minutes on this one, it's a piece. All right, here we go. In honors, I gave them a few different choices of how to tackle this. You guys, we're just going to implement a system and we're all going to use it, okay? If some of you figured this out last night, really cool, just make sure that your system works. But otherwise, the rest of us, we got stuck somewhere earlier in homework because you guys seemed to have a good attempt in homework, which was good. You guys were trying, but you got stuck. Follow my system, I'll simplify it, okay? The formula, difference quotient. If I were you, if you were like a highlight or a star, you're going to want to highlight star this formula. It is given in the problems on the test, and I promise it will be given. But we need to figure out how to use it. And it might show up different ways in different examples. The long story short of difference quotients, this is one form of the difference quotient. This is the basic form. And you should think formulas before we even go there. Can someone give me an example of any formula? I don't care. Any formula that's true that you've used before in science, in math, in chem, I don't care. Formula. Quadratic formula. X equals negative b plus or minus square root of b squared minus 4 is b all over 2. Okay. Quadratic formula. How do you use the quadratic formula? You have a quadratic, and what do you do? What do you always do in formulas? Plug stuff in. True? If you have distance equals rate times time, you plug in rate, plug in time, you get a distance. If you have density equals
Mass over volume.
Got it. Mass over volume. You have to plug in mass, and you have to plug in volume to get density. Okay. This is a formula. You gotta plug in what is f of x plus h. You gotta plug in what is f of x. But the minus and the divide and the h stay the same. You gotta think, what do I need to plug in? Now, in this example down below, okay, do you see an f of x? Okay, we see him. We don't need to go looking for him. It's given to us. So what don't we have stated for us? F of x plus h. So how do we find f of x plus h? If we're given f of x, what am I doing? I'm saying, oh yeah, that's right. I can change the inputs. Hasn't the input been changed? So what am I going to do to the rest of the formula? Change the input. I'm going to do what function notation taught me. And if it's not an X, if it's something else, all right, fine, no big deal. Put that in the input spot. Now, being a math student, am I going to have to simplify? Yes. I'm going to go quickly for sake of time. You would need to FOIL. You would get 2hx. You would need to distribute the negative 4. You would get all of this for f of x plus h. But what is my end goal? To get f of x plus h? No, it's to get this guy. So now I have all the pieces to plug in. So I can say division minus h. I need to plug in my f of x plus h. I need to plug in my f of x, which I can do very carefully. What's the name of the game once you plug into a formula? Simplify. When you simplify, the bell rings, just wait, simplify with me. As soon as we finish, you will leave. Simplifying, I have x squared plus 2hx plus h squared minus 4x minus 4h plus 7. I distribute my x squared, the negative, and then I ask myself, any like terms? Then I say, oh, this is nifty. Everybody left has an h. So I pull out an h. Even the h's cancel. And I'm left with my final answer. Difference quotients can show up, difference quotients can show up in different ways, but every time it's a formula. Identify your pieces, plug in, simplify. Bye guys, I'll see you tomorrow. Finish up 1.4. We'll go over questions. It is on the video. Slow me down tonight. Look over the example again, see if you can follow. Bye guys. Only questions for see you tomorrow. Have a great day.